Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali and my role ID is 190994. So today I'm going to introduce you about the introduction and implementation of external and PC interrupts on ATMEGA 328P on Proteus simulation as well and on hardware as well. So first of all we have to introduce about the basic introduction to interrupts. So our objective is to introduction to external interrupts and also as PC interrupts. The software we are going to use in this simulation purpose are the AVR Studio and Proteus ISI. So the hardware tools we are going to use at Mega 328P for our code burner and for potentiometer, for our liquid crystal LED and hex keypad as well for giving any input or another purpose. So we can easily use push button to giving any interrupt or any disturbance. So first of all we have to introduce about the interrupt. So we will talk about the first type of device interrupts called external interrupts. These interrupts are basically called on given status change on the INT pin. So this is essentially an input interrupt and is great to use for application when you might need to react quickly to an outside source, such as a bumper of your robot hitting the wall or to detect a blown fuse. So hardware wise there is no difference between external interrupts and inputs. If you look at the AVR pinout, you will see the input which are used for external and as well as other pin chain interrupts. So these are the some digital and analog pins of ATMEGA 328 pin mapping. So we can easily use these pins as an external or interrupts or PC interrupts for displaying on our simulation or on our hardware or on our other applications. So this is a basic introduction about that Mega and where we are working on our falling edge and our rising edge as well. So this is on falling edge will trigger at the moment the pin goes from high to low, while on rising edge the pin goes from low to high. So this will distinguish us between the interrupts. So we have this lab task. So this is the basic AVR HTML code for our creating interrupts and displaying it on our liquid crystal display. So first of all, this is the LCD 11.header files. So this header file is created by us as in the previous labs. We are discussing about the proper code of our LCD. So this is the header file which we are making, and now we are defining here for our interrupt code. So first of all, we have to declare the output ports B and C with the help of direction register, and then we have to call the LCD initial function, and then we have to set the port D as an input. So now we are going to move towards our another ports. So after defining all the outputs and all the inputs of ports with the help of direction register, we are going to move towards the inputs we have to enable or not. So first of all, you can see here we have to apply the condition port D 1 less than equal to 0. If port 2 is now an input with pull up enabled, now we have to set the port 3 input as an pull up enabled, and after it we have to set the interrupt 0 to trigger on any logic change, and after it we have to on the interrupt. So after setting all this, we have to call the CI function to turn on the interrupts. So in this case, first of all, we have to print the waiting on the LCD string, and with the help of a delay, when we are calling some command 0x01, we have to call the first interrupt. So now this is the function for our first interrupt. When we call this command 0x01, our string will display interrupt 01, and after some delay it will clear the string bar, and then again appear waiting. So at this port, when we second press the second push button, then it will display our second interrupt. So after it we have to call the delay function, and then it will clear the command window. So now this is the Proteus simulation of our interrupt. So now I'm going to show this simulation on Proteus as well. As now you can see here, I have uploaded the hex file on this Arduino 8 so after importing hex file of interrupt, I'm going to show you the basic phenomena and basic process on simulation on Proteus. As now you can see here, first it will display waiting. When I will press the first button, it will display first interrupt, and after 1 millisecond display, it will again display waiting. And now if I press the second push button, it will display interrupt 1, means second interrupt. So this is the basic Proteus simulation on our Proteus. And now I am going to show you the on the hardware as well. So this is the hardware uh, implementation of our interrupts on hardware as well. So now I'm going to show you the hardware implementation of our interrupts. So now you can see here, this is our hardware implementation of interrupts on LCD with the help of ATMEGA 328P. सो ये हमारे पास इंटरप्ट की बेसिक इम्प्लीमेंटेशन है हार्डवेयर पे। सबसे पहले हमारे पास एलसीडी पे शो हो रहा है वेटिंग फॉर इंटरप्ट। सो ये हमारे पास दो पुश बटन है। सो एक इंटरप्ट 0 के लिए और एक इंटरप्ट 1 के लिए। सो ये हमारे पास प्रोटियस पे सिमुलेशन है जो कि वेटिंग फॉर इंटरप्ट शो कर रहा है। ठीक है, अब जैसे ही हम एक पुश बटन प्रेस करेंगे तो वो हमारे पास इंटरप्ट 0 शो कर रहा है, और जब हम दूसरा पुश बटन प्रेस करेंगे तो वो हमारे पास इंटरप्ट 1 शो कर रहा है। सो ये हमारे पास हार्डवेयर इम्प्लीमेंटेशन थी इंटरप्ट्स की। सो दैट्स ऑल फ्रॉम आवर साइड। जज़ाकल्लाह।